destination. Today we will look at an RV mobile internet solution done on a budget. Although we are not full-time RVers, I do have to work from the road once in a while, and I need solid internet to do so. On top of that, we want to be able to stream to our TV, YouTube, Hulu, etc. So internet is necessary for that as well. Being 100% Dutch, so cheap, I have a tendency to try to find alternative solutions to popular products. And in this case, I think I succeeded. There are several great LTE router options available for RVers, but they all come with a hefty price tag. My solution is using a Raspberry Pi 4, a mini computer costing less than $100. And in my case, I already had one laying around from other projects, so I repurposed it and it didn't cost me any money. This Pi will serve as the main router, an ad blocker, as well as an internet network load balancer connecting to two modems. One is the Netgear Nighthawk for AT&T. The second one is the Netgear 8800 to connect to Verizon. And as our access point, we'll repurpose a Netgear Wi-Fi router that I also had laying around. I would like to preface this that I'm not an expert in internet technology, networking, any of that. I have experience with Linux. I do have a bachelor's in computer science, so I know the basics, but I'm no expert. So if someone has any suggestions on how to do things differently or more efficiently, let me know. But for now, let's get started. See how this all works. First, we will need the Raspberry Pi Manager. So let's download that. We'll go to raspberrypi.org. Click on Software. And in my case, I'm using a Mac. So I'm going to download for Mac OS. If you're using Windows, use the Windows option. Download it. We'll get it installed right now. So just drag it over to the application folder, and it is installed. Next, we will need the image to put on the Raspberry Pi, and we're going to use OpenWRT. So we're going to go to openwrt.org. Click on Downloads. Since we're using a Raspberry Pi 4, we'll need a snapshot build. It's the BCM 2700 series, then BCM 2711. Here we'll find the image. So we're going to download that and extract it. Click on it to download. And extract. Next, we're going to image the SD card for the Raspberry Pi. I'm going to insert, I've got my micro SD card and my adapter. I'm just going to insert that in the USB drive. Open Raspberry Pi Manager. We're going to click on Choose OS. We're going to use Custom. To our Downloads folder. We're going to find the Raspberry Pi image right here. Open. Choose the SD card. And say write. We want to overwrite the card. So I'll ask for admin privileges, so you have to enter your password. So at this point, we wrote the image to the card, and the next step, we'll have to resize the partition on the card to make sure that we optimize the capacity of the card. As macOS does not have the ability to resize the partition on an SD card, we're going to use Gparted, but unfortunately it's not available on macOS, only on Linux. So we're going to use Virtualbox to have a virtual machine that runs Linux and run Gparted on that to resize the partition on the SD card. So first we'll start with installing Virtualbox. So Virtualbox download, search for that. Click on downloads. And we're gonna click on OS X hosts since we're using it macOS. Download that. And there's one more thing while we're here that we need to download, which is the extension pack. So I'm going to click on all supported platforms down here. Download that. It goes pretty quick. Then we're going to install Virtualbox. Alright, so it opens the package. We're going to double click on Virtualbox.package. Continue. Install. Type in your password. So when you get this message, say open security preferences. You need to unlock it. Type in your password. And down here say allow. Installation was successful. Close this, move to trash. Close that. Now we have to install an extension that we downloaded. So we're going to click on. If you can't find it, you can go to your downloads folder. It will be right there. Double click it. Virtualbox will start up and say install. Agree. Your password again. Okay, at this point I recommend that you restart your computer just to make sure everything will load correctly. Next we're going to download the ISO image for Ubuntu. So Ubuntu download. Download Ubuntu desktop. Select all visit and then click on download. Next we will start Virtualbox and create a new virtual image to run Ubuntu. Let's go to Virtualbox. Click on new. Say Ubuntu. Let's type Linux, Ubuntu 64-bit. Continue. 4 gig. Continue. You will have to create a new virtual disk. DDI dynamically allocated to make it 5 gigabyte. Create. Now in settings, we'll have to attach the ISO that we downloaded. We'll put it under the IDE plus optical drive. Add. Find the ISO. Say choose. Click on the ISO name. Live CD. And lastly, we'll have to attach the SD card to the image as well. So we'll go to ports, USB, select the USB 3.0 plus, and then select your SD card. So now it will be available to the virtual machine. OK. Start. And this will create a new window. And it should automatically boot from your ISO. Now that the virtual image is finally booted up, we're going to click on Try Ubuntu, and it's going to actually start Ubuntu. We will click down here to show the applications, and we'll find Depart here. If your SD card doesn't show up right away, you can eject the card. It's showing here. Reinsert it while Ubuntu is running, and it should pick it up. It's showing right here. And we're going to click on this partition arrow to resize. Drag it all the way to your right, and say resize move. Click the check mark, say apply, and it will resize the partition at this time. So we'll let that do its thing, and then we'll continue on to the next step. This message shows that the resize was completed. Click close. And at this time, we don't need the virtual machine anymore, so we're just going to power off the machine. So the next step is to take the SD card out of your USB reader and then insert it into the network port or into the SD slot right there. We will attach a network cable between the computer as well as the Raspberry Pi, and then we'll plug in the power. We will let the Pi boot up, and in the meantime we will disable Wi-Fi because we have our network cable connected to the Pi, and we don't want to have any IP address conflicts. So we have that disabled. We will connect to the Pi, the Ethernet connection, using SSH, and the username is root at 192.168.1.1. That's the default IP address. We're successfully connected. Now we have to enable the Wi-Fi radio. You see I said wireless dot net Wi-Fi device 0 dot disabled equals 0. UCI commit wireless, commit those changes, and then Wi-Fi. Next step, we're going to scan for networks to make sure it works. IW dev WLAN 0 scan. See a whole bunch of networks. We'll edit etc/config/wireless. We will not be using this, so we'll delete this. Let's verify that this is all correct. Disable 0. Now we're config. Wi-Fi high face option network. We'll give it a name Wi-Fi 1. Option SSID. This is the SSID of your wireless network. Got it here. Option encrypt. encryption, PSK2, option device, radio 0, you can see that above, option mode, STA, option get name, we'll call it WLAN 0, option key, and this is your Wi-Fi password key. So we've done that. We will restart wireless, service wireless, restart wireless, Wi-Fi. Now we will edit the network file, etc config network. We'll create a new one here. Config interface, and we'll use the same name, Wi-Fi 1. Option proto, product protocol, DHCP. Save that. Here we will restart network services, service, network, restart, and IP space A, see if it came up. See an IP address here, so we'll go into etc config network. We will add the gateway. Which is our actual Wi-Fi router. We'll add option DNS 1.1.1.1 and we'll change the IP address occupy to 199. So we'll save that. Want to restart the network services. And since we changed the IP address, we'll lose connection here. In that window, start a new one. This is its root 192.168.1.199. So we change it to that. See if it's booted up. Boot it up. Let's make sure we can access the internet. Okay, so that's successful. Excellent. So we'll move on to the next step. First, we'll run an update on the system. AT&T update. We'll just pull all the latest package definitions down. I'll let them finish. Then complete it. So now we're going to install a bunch of packages. OPKG, install HTOP, IFTOP, TMUX. We'll install the OpenWRT Lucy web interface using Lucy, SSL, NGI, and X. Then we'll need some more packages for the SSL Open, SSL Util, Lucy, and HTTPD. And for the AT&T and Verizon modem, we'll need some packages, KMOD, USB NET, RNDIS, and USB mode switch. Then for load balancing, we will use MWAN3, MWAN3. So Lucy, app, MWAN3. And for our ad blocking, we'll use AdGuard Home, PD. We'll use AdGuard Home, so we'll add that package as well. We'll let that run. comes with a generic certificate. It will give errors when we try to access it through Chrome. So we'll have to install a system-specific self-generated certificate. Search for OpenWRT, get rid of Lucy HTTPS certificate warnings. How to get rid of Lucy certificate warnings. We'll open that up. Switch back to terminal, connect, root, and 192.168.199. We will switch to the directory etc/ssl mycomputer.com. The instructions are right here, but we're going to take this portion. We'll copy that to our system, and we're gonna enter our final IP address. Instead of staying in the 192.168.1 range, I'm gonna switch it to 2 range, so 2.1 at the end. We will update some of this information. Texas, some city in Texas, and this is going to be our RV router with that IP address. So let's save that. Some instructions down here. We'll copy this over. Paste. So we'll have a few new files in here, the CRT file and the key file. We'll have to copy those certain files over to where Lucy reads them. So copy mysearch.crt to etc httpd.crt. So copy cp mysearch.key to etc httpd.key. Now, before we reboot the system, let's update something for AdGuard Home. By default, it reads the temp folder for all the information. When you reboot Pi, the temp folder is cleared. So let's determine what service is running. Type service, and we'll see AdGuard Home at the top. It's that file, so we're going to edit that AdGuard Home, and you'll see that it's reading the TMP folder. Let's change that to root. Save that, and then we'll make a folder called root AdGuard Home. At this point, we will make a change to the IP address once again to match what the certificate says. So di etc config network instead of this to 2.1. Actually, at this point, going to eliminate those two, and we will reboot the Pi. Let's reconnect to the Pi SSH root at 192.168.2.1. If you run into this error, just have to open the file you're referring to and delete that entry and return. So accept their fingerprint. And we will stop MWin 3 for right now because it hasn't really been configured. And then we will open up Lucy. New IP address. We have not set a password. You can. You have to do that on Linux. I'm going to leave it open for right now. Then we'll go to Network, HTTP and DNS, Advanced Settings. We have to change the default port here for the DNS server. We will not be using this DNS server. We will actually use the one from Edgard Home. So we'll change this to 5353 so Edgard Home can listen on 53. So apply that. And then we will go to port 3000, which is the installation folder for Edgard Home. Let's get started. We're going to listen on 8080 for the web interface. We leave this DNS port to 53. Let's see next. We will create a username password combo here. Next, open the dashboard. Log into the dashboard. So that has come up. Then we'll go into filters, DNS block list, activate those two, and a block list, choose from list. I'm going to add spam 404. And check for updates. No updates. So Edgard Home is set up now. And we'll the next step will be to set up MWin. So the next step we're going to focus on is our AT&T modem as well as our Verizon modem. So we will connect those with USB. So we will connect the modems one at a time. So I will first connect my AT&T modem. Use the blue ports on the Raspberry Pi 4. Those are the high-speed ports. We will connect that. Now let's see if that got picked up automatically. The message. I found the port and it decided to Ethernet 1. So the next step is to edit the network configuration for that. Config interface. It's called AT&T. Option type. Option IF name. 1. Option Proto. DHCP. Save that service network. Restart. Let's see if we have an IP address for Ethernet 1. We do. Let's see if we can access the internet through there. Ping google.com -I and then ETH1. Okay, we have responses there. Excellent. Right there. We'll attach our second modem on the Pi, send the message shows that it registered Ether 2. So we'll edit our network file once more. Okay, interface, Verizon. Option, I have name, Ethernet 2. Option, protocol, DHCP. Service network, restart. And let's see if we received an IP address assigned. Ethernet 2, we have an IP address. Ethernet 2 is 1.3. Ethernet 1 is 1.4. So network Ethernet 1 option gateway 192.168.1.3. Or let's double check. Zero route 3. Start. Let's see, IPA. Okay. Google.com. Ethernet 1. There we go. Ethernet 2. And there we go. Okay, next step is to actually configure the load balancing for the network. So Lucy. Go to load balancing. Or let's double check our interfaces. We have to make an update here. So we have to make a priority. First, let's set a firewall. These are all internet access, and we'll use a metric. Wi-Fi metric is 5. Edit this one. Set this one to 10. Say Wi-Fi or the WAN firewall. See here. Set firewall to WAN. Set this to 15. These you need to be unique, but we'll define the actual rules for MWAN 3 in a little bit. So save it 5. And there's one more change I want to make here. We want to send the DNS server. So in DHCP options, we'll add 6 comma, then the IP address. That one. So as soon as you pass this along, it will actually use Edgard Home as the DNS server, and it will filter out the ads. So we have this configured. Let's see. Restart the network. Make sure we can still access everything. That's still looking good. So now we have to take note of these names. We have Wi-Fi 1, AT&T, and Verizon. So go to load balancing. We will remove everything that came in by default. All these. Policies. Okay. We will will leave rules, but we will set up everything else. So interfaces, we'll add Wi-Fi 1, enable it, tracking hostname 8.8.8.8 plus 8.8.4.4 plus, save and apply. Next one, AT&T. Enable. Save my IP address. 194. Save. We'll add Verizon. Enable. 8.8.8.8. 8.8.4.4. Save and apply. So now we have defined our interfaces, which are the same interfaces as we've defined for the network. Now we will add members. So let's add Wi-Fi member or interface Wi-Fi 1, metric 1, weight 1. So if by some miracle the campground has good Wi-Fi and good internet speed, the Wi-Fi will be first priority in our routing. So if we have both, if we have the modems attached but we have the Wi-Fi, it's not going to use the modems, it's just going to use the Wi-Fi. If we don't have Wi-Fi, it will load balance the two modems. So we'll set AT&T member or AT&T metric 2 weight, and the higher this weight, the higher the priority this one will have in the load balancing. So I prefer to use AT&T more than the Verizon one. So we'll set a high priority there, or a higher weight there. And then Verizon member, that's into Verizon. The metric will be 2 as well, but we'll have a lower weight. Now in policies, we're just going to set up one policy. Policy 1. We'll use Wi-Fi, AT&T, and Verizon. Save that. And we'll assign that new policy to our rules. Policy 1. And this one as well. We're not going to worry about version 6 for IP. Just focus on version 4. If you would have version 6, I have not really worked with that, but you would set up initial interfaces for version 6 here. Set up members, tie it to a policy, and set up the rules, but we're not going to do that today. So let's restart and when 3. And still access the internet, so that's good. Now let's see if our AdGuard is working. So go to 192.168.2.18080, which is what we defined earlier. Now let's open the site. Known to have a lot of ads. Forbes.com. Statistics. See the next block here. One other thing that we can look at is load balancing here. We have all three active. By default, it will use that one if available. It will load balance between those two. So there you have it. Mobile RV internet on a budget using a Raspberry Pi 4, OpenWRT. Have load balancing between the modems. Have Wi-Fi as a priority. The next step would be to just connect the network cord from the Raspberry Pi to the router input, boot up the router, and use the Wi-Fi to connect all your devices for streaming, your laptop, phone, whatever you want to use. So far it's been working great for us. If you have any questions, just put it in the comments below. And we'll see you in the next video.